Students, block coding की discussion चल रही है. The second technique in our digital data to digital signal conversion. Or students, before we move on to the third technique, which is scrambling, let's do a example of the block coding and see how this block coding impacts the signal rate and how it solves the problem of synchronization. Now, students, इस example में we need to send data at a rate of 1 megabits per second. We need to find out what is the minimum required bandwidth while we are using a combination of 4B, 5B block coding scheme and NRZ-I or Manchester coding. Students, एक comparison हम लोग करेंगे कि NRZ-I के केस में required bandwidth क्या है और Manchester coding, which is an example of biphase coding, उस केस में इस block coding को use करते हुए what is the bandwidth that we need to send data at a rate of 1 megabits per second. Students, हमारे पास जो data rate है, first of all, that is 1 megabits per second. Now, students, straight away, because we are deploying 4B/5B block coding scheme, this essentially means that for every 4-bit group, we will replace that with a 5-bit group. हमारा data rate जो है, because of this, it will go up, and that will be 1.25 megabits per second. So students, in this particular case, because we have a higher data rate, our signal rate, an observation is that our signal rate will go up as well. So our signal rate is increased. अब students, इस particular case में आप ये भी देखें कि the minimum bandwidth that is required for NRZ-I, हम लोगों ने line coding schemes की discussion करते हुए study किया था that the minimum bandwidth required is half the data rate, and that is 1.25 megabits per second divided by 2, and this comes out to be 625 kilohertz. Students, याद कीजिएगा, Manchester, which is once again an example of biphase line coding scheme, it requires a minimum bandwidth of 1 megahertz. So students, summarize करेंगे इस पूरी discussion को of block coding. As you saw, using block coding, we have solved the problem of synchronization that we had in NRZ-I line coding scheme. So this is solved. Students, signal rate went up, which means that the amount of bandwidth required has also gone up, but we have seen that this amount of bandwidth required for NRZ-I is still lesser than amount of bandwidth required for Manchester. So we are still good. This is a tick mark as well. Students, a disadvantage of using block coding is that we still have not solved or gotten rid of the DC component problem. So students, in this slide, as I have explained to you, a 4B/5B block coding with NRZ-I, we have converted 4-bit blocks/groups into 5-bit groups. If we are employing NRZ-I, we essentially need a lower bandwidth, but we have a DC component problem. For Manchester, we saw that we need a higher bandwidth, 1 megabits per second, but it does not have the DC component problem. So the choice is yours, depending upon whether you want to do a dedicated line communication or whether you want to remove the DC component because you have got a long distance communication. You can choose either ones of the NRZI or Manchester with the block coding, and that will solve your synchronization as well as your DC component problems. Students, one more example before we leave this topic. We have got an 8 binary / 10 binary block coding scheme as well. It is very similar in concept to the 4B / 5B that we just did an example for. But in this case, a group of 8 bits of data is now substituted by a group of 10 bits. So in this particular case, the value of M is 8 and the value of N is 10. And students, this is a 8B / 10B is nothing but a combination of 3B / 4B and a 5B / 6B block coding techniques. Students, an additional concept out here which is noteworthy is that we have used a disparity controller. What this is doing is, because we are deploying 2 different techniques and it's a 8B / 10B block encoding, we need to prevent a long run of consecutive zeros or ones. So in this particular case, 8B / 10B uses a disparity controller, and this controller keeps track of excessive zeros and excessive ones, and it controls it before it converts it into a 10-bit block.